Hello friends, in Industrial Instrumentation lecture series, today we will see about the measurement of flow using orifice plate. First of all, let us start with introduction. An orifice meter is basically a type of flow meter used to measure the rate of flow of liquid or gas, especially steam, using the differential pressure measurement principle. As the name implies, it consists of an orifice plate, which is the basic element of the instrument. When this orifice plate is placed in a line, a differential pressure is developed across the orifice plate. This pressure drop is linear and is in direct proportion to the flow rate of the liquid or gas. Now let us see the principle of operation of orifice meter. The orifice plate inserted in the pipeline causes an increase in flow velocity and corresponding decrease in the pressure. As we can see in this figure, there is one pipeline and the orifice plate is inserted in this pipeline. The differential pressure instrument measures the differential pressure. The flow pattern shows an effective decrease in cross section beyond the orifice plate with a maximum velocity and minimum pressure. The flow pattern and the sharp leading edge of the orifice plate which produces it are of the major importance. The sharp edge results in an almost pure line contact between the plate and the effective flow with the negligible fluid to metal friction drag at the boundary. Now let us see the construction of orifice plate. As we can see in the construction of orifice plate, there is a inlet section, one outlet section, and orifice plate is inserted between this pipe. So let us see first of all about the inlet section, a linearly extending section of the same diameter as the inlet pipe for an end connection for an incoming flow connection. Here we measure the inlet pressure of the fluid or steam or gas. Now the orifice plate. An orifice plate is inserted in between the inlet and outlet section to create a pressure drop and thus measure the flow. Outlet section, a linearly extending section similar to the inlet section. Here also the diameter is the same as that of the outlet pipe for an end connection for an outgoing flow. Here we measure the pressure of the media at this discharge. And the material of construction of orifice plate. The orifice plate in the orifice meter is generally are made up of stainless steel of varying grades. Now let us see the working of orifice plate flow meter. As the fluid approaches the orifice, the pressure increases slightly and then drops suddenly as the orifice is passed. The decrease in pressure as the fluid passes through the orifice is a result of the increased velocity of the gas passing through the reduced area of the orifice. When the velocity decreases as the fluid leaves the orifice, the pressure increases and tends to return to its original level. All of the pressure loss is not recovered because of friction and turbulence losses in the stream. The pressure drop across the orifice increases when the rate of flow increases. When there is no flow, there is no differential pressure. The differential pressure is proportional to the square of the velocity. It therefore follows that if all other factors remain constant, then the differential pressure is proportional to the square of the rate of flow. Now let us see the type of orifice plate. There are basically four types of orifice plate we can use in orifice meter. First one, that is concentric type. Second one, that is eccentric type. Third one, segmental type, and the fourth one, quadrant edge type. Here the construction of all these four type of orifice plate is we can see in this figure, and the use of this different type of orifice plate is depending upon the fluid. It may be a gas, it may be a, we can say, pure liquid, right? Based on that we can use this different type of orifice plate in orifice meter for the measurement of flow. Now let us see some of the advantages of orifice meter. The orifice meter is very cheap as compared to other types of flow meter. Less space is required to install and hence ideal for space constrained applications. Operational response can be designed with perfection. Installation, direction, possibilities vertical, horizontal or inclined. Now let us see some of the limitations of orifice meter. Easily gets clogged due to impurities in gas or unclear liquids. The minimum pressure that can be achieved for reading the flow is sometimes difficult to achieve due to limitation in the vena contracta length for an orifice plate. Unlike venturi meter, downstream pressure cannot be recovered in orifice meters. Overall head loss is around 40% to 90% of the differential pressure. Flow straighteners are required at the inlet and outlet to attain the streamlined flow, thereby you can say increasing the cost and space for installation of this orifice meter. Orifice plate can get easily corded with time, thereby entails an error, and discharge coefficient obtained is low in the orifice meter. Now let us see some of the application of orifice meter. The first one, we can measure the flow of natural gas, water treatment plants, we can say oil filtration plants and petrochemicals and refineries. In all that kind of application, we can use orifice meter for the measurement